answers after the talk. And now, without further ado, Dr. Aron Kamajaya, take it away.
All right, so let me share my screen. Yeah, first of all, I feel I'm humbled and to be presenting to you guys. I'm a new PI, and I also feel very privileged to get a lot of support from this Innovate Bio community as well as DNA Learning Center at Cold Spring Harbor. So yes, my name is Aron Kamajaya. I am a new PI at NSF. Our project started in September last year. So since I'm a newcomer, I guess in the Innovate Bio, I'll introduce myself a little bit more, who I am in here. So that's me. I'm actually graduated from Pasadena City College Biotechnology program. At one point, I was a biotech student at community college. And I was one of those typical community college student who was like the dream come true would be just to graduate with a bachelor degree. That's sort of like a far-fetched dream at that time for me. And then I found biotech program, and that opened up a lot of possibility, and that allowed me to go transfer to UC Berkeley, doing some research in biochemistry, did some research at Caltech, doing my PhD there, working on membrane protein structure of membrane protein that includes this piezo protein. I don't know if you heard about the piezo protein. The person who discovered it received Nobel Prize last year, Aron, and he was the one that got me into working on piezo channel at that time. So, and then ever since then, once I graduated, I now get a faculty position here at Pierce College, trying to pay it forward so that students at community college get the same or even more opportunity than I have as a student before. In addition to that, here you can see in the picture over here, that was my lab partner at the time. She also went to Berkeley, and then after that, she decided to go to industry right away, starting as a research associate, laboratory manager, project manager. Now she's a program manager overseeing millions of dollars project in a formulation company. So, and the reason why am I telling you this? Well, the reason why is because I know sometimes, applying for, as a community college faculty, applying for a grant like this project, it may sound like extra effort on your part, and sometimes if you may be feeling tired and everything seems to be too much for you. But I just want to remind you something that you already know: what you do actually matters, because people like me able to get this opportunity, and you're kind of like giving ladder for a student like myself at that time to climb up this social mobility in a way. So okay, so now that I'm here, let me talk a little bit about the Aspire project. Here, Aspire it's a long acronym for Advanced Student Focused Project that has 3 pillars: internship, research, and education. That's the I, the R, and the E. So those of you who are still remember your biochemistry, this Aspire actually also a 1-letter code for amino acid, and the structure of that amino acid is become our logo right there: alanine, serine, proline, isoleucine, arginine, and glutamic acid. So so let me just, this is a partnership between Pierce College and the DNA Learning Center. The co-PI on this grant is Bruce Ness from DNA Learning Center, who's also here with us today. So let's just, let me just talk a little bit about the 3 pillars that we have. Let me start with the E, the education part. This funding support the development of our biotech program. It's aimed at establishing the training program at Pierce College. We do not have a program yet, so but we are going to start our first cohort this fall. So basically, it involves the small certificate and the internship program, along with the potential specialization in the agriculture biotechnology. So here, so far, we got 5 courses, 5 credit courses approved in our institution after some time, some effort. And as this is actually quite interesting because myself, I'm a new faculty at Pierce at the institution. In fact, I just get my tenure this past fall, and it's very I felt that it's the support that we got from my admin it seems to be increases due to the fact of we have this grant, and that actually enable us to get some more support, and our admin actually offer us the sort of like this outreach recruitment course that we plan to have this summer, and that's going to be our non-credit pathway. So we have the also the two, basically the yellow one here is the biotech specific courses. So we got the two non-credit courses. One is aimed at the exploration in biotech career, because most students, just like myself when I was a student before, most students coming to community college, if you survey all students that taking life science or chemistry course, ask them, what do you want to be? Most people are thinking about this patient care related career, like nurse, medical school, pharmacy, things like that. So this exploratory career exploration course is meant to broaden their horizon, to see what's other opportunity out there, to inform them about this biotech career that has really high demand, particularly here in California. The other exploration course is a part of our another project with Cal State LA, California State University, Los Angeles. This one is to basically exploration course in biotech entrepreneurship. So that's another exciting thing that I can talk about, but it's I'll skip it for now. Instead, what I want to do now, I want to talk mostly in terms of our internship, the second pillar, the I. Right, so here our internship, we partner up with Cold Spring Harbor, the DNA Learning Center at Cold Spring Harbor. This is actually what makes our program special. In addition to offering biotech training program, we also offer internship. And I think even though there's high demand for biotechnician in the region, and we know how crucial it is to get that internship, which gives students the opportunity to have sort of like work-based, like real world work-based type of experience. The internship opportunity, just like our first speaker mentioned, is very limited in the area as well. And our hope is by offering this in-house internship in protein biomanufacturing, we can increase the amount of internship opportunity for the student in the area. So we do, with collaboration with DNA Learning Center, we were able to obtain the construct for Taq polymerase. So we choose Taq polymerase as our first target for several reasons, because the primary reason is because many bioscience learning community will benefit from that. So we are hoping to create this in-house, and then hopefully once we optimize the protocol, we can distribute it to different institutions. And this is actually, we already have sort of like the end user per se. I know I list this organization like the end user, but actually they are also not just the end user itself, but they also play crucial role in supporting our program. So DNA Learning Center, also Amgen Biotech Experience, as well as Innovate Bio. So in the picture here, what you see here, it was the first time we had it, the first time we heard, oh, we get the NSF grant. Our partner at Pasadena Bio Collaborative Incubator help allow us to sort of like have a space, laboratory space over there, where we had 5 students to help me build the protocol and get us started even before the funding arrived. So we actually have 2 students here and there from other college, Los Angeles Mission College. We have 1 student from Pasadena City College and 1 from Pierce College right here. And then there's 1 high school student working to develop the protocol. So we're very grateful for the support that Pasadena Bio Collaborative provided to us. So and then so here and then in the fall, we do actually have well, we partner up with high school, Reseda High School, which is very they were able to send us 12 student intern, and here I just have video just to show you what we've been doing. So here, let me play the video.
Hi, I'm Aron Kamajaya, the director of the Aspire Biotech Training Program here at Los Angeles Pierce College, supported by the National Science Foundation. In this video, you are going to get a glimpse of what our students are doing in the Aspire Training Program. They perform independent research projects commonly found in academic research institutions, as well as industry-specific activity such as validation, inventory, supply chain management, as well as manufacturing. Welcome to our very first student reflection event.
All right, so that's our video that we showed in our first student reflection app event that happened this past December. So, okay, so in addition to this basic lab maintenance, biomanufacturing media, bacterial media, and things like that, we also, as I mentioned, we work on protein biomanufacturing, and we choose Taq polymerase as our first target. The reason why is because we can benefit the most number of bioscience learning community. And not only that, that's actually very simple to produce also, and we are able to get the off-patent construct for that. So what we do, the way you to do is basically you express the gene, Taq polymerase gene in E. coli, and then basically you boil them up. You put in the high temperature, so all the E. coli protein will aggregate, and we spin them down. Everything come down. Hopefully, you left with Taq polymerase. That's the hope, right? So, but as you can see here, I'll show you our journey, which is not perfect. So, but here we go. So the first time we did it, we got the construct from DNA Learning Center. We tried it. And here is just the gel image, the supernatant after you spin them down, right? So we have that, and then we look at that, and then I know that the Taq polymerase is supposed to be about 93 kilodalton, and then we saw it was not 90 kilodalton. So it's that we were not sure whether it's the wrong construct or something like that. So the student actually involved in here, and then basically we decided to try to do functional assay to see if it actually work at all. So we did we did the PCR reaction using the only primer we have. This is actually come from a different sort of like other side hustle we have. trying to develop barcoding for microbes, like using the 16S primer. So this basically we have two sets of primer for 16S RNA sequence. One is covering this variable region number 1 to 3. That's the red one right here. It covers about 500 base pair, and the other one covering variable region 4 and 5, which give you about 400 base pair. So we basically, okay, so we got this purification. It doesn't look promising to us, but let's try it anyway. Okay, so we try it, and voila. So you can see that we actually get no amplification. So you can see from there, this is just a different strength of different amount of tag polymerase we put inside. Essentially, 1x corresponds to 1 microliter of tag extract in 25 microliter PCR reaction volume. That's basically what 1x is. Half x is just half as much tag extract, and so on and so forth. And this is the NEB is our control to show that we actually can do colony PCR. Although that's basically our positive control. So this is our 400 base pair band. I know we should have used the different DNA ladder, but that's the only one we have in our facility right now at the current moment. But anyway, so we redo the purification, expression and purification. Again, this time we use two different background strain, doing different temperature, induction time, things like that. We try to optimize the expression, and we have this really good high school students helping us at that time. And after we run the gel again, we saw that, which is a different profile, and we saw, oh, what is this between 75 to 100 kilodalton, and then we're all very excited about this, like sort of literally jumping when we saw that in our gel imager. So we had a good feeling about this. We started to okay, so the next step will be the another functional assay, round 2 kind of thing, So here this happened in the winter time. This is around January and February. So you can see this is I'm showing you work in progress in a way. So on January we got another 4 Pierce College student, actually 3 Pierce College student, and one of them from Los Angeles Trade Tech College, which is another program in our area. So here, so the two of them actually coming from the bioscience club that we have on campus, and they're actually looking for lab experience. So even though this Aspire internship is meant for people, biotech graduate, to give them real world experience, but we do accept anyone that actually looking for, sort of like looking for some lab experience, especially coming from pandemic era where all the lab are online, the online lab. So here basically we give them some opportunity to have lab experience. And here actually the student in my microbiology class, he's actually a professional chef for 25 years, and he's actually really have a really good hand. So in fact, he actually mentor many of these students and lead the project that I'll show you some of the data in the next few slides. So here's the data that we have from that batch. Again, the 1x, 0.25x, 0.5x, this is just equivalent. For 1x, it's equivalent to 1 microliter of reaction. Essentially, we were able to get amplification. Although if you push the concentration higher, you can start seeing that the non-specific amplification over there at the top over here. So what's important from this piece of data is that we are confident that that our the amount of tag polymerase we produce is equivalent to is enough for us to only use 0.5 microliter in one PCR reaction, which is basically just comparing it to the amplification amount that's from the commercially available NEB. Okay, so of course this is not ideal. If you want to do the better sort of like QC for this, we will have used the plasmid instead of doing colony PCR, right? So we know exactly how much nanogram of DNA we use, and even better, we actually have to use the qPCR to get more quantitative data. So we are working with Bayback right now to get the lambda DNA and the primer for that, and we're still waiting for our qPCR machine because it's back ordered right now. So, but nevertheless, we will continue to improve our method in this regard. So for the sake of time, I'm going to skip quite a bit. Basically, here upon calculating how much in terms of how much amount we make in here, we are somewhat confident to say that we make enough for 10,000 PCR reaction from 40 mil of E. coli culture. Although we do have about 4 batches of that, so we actually have 40,000 PCR reaction just from one purification. And here we actually just show, again, this is another data from different batch. I was just telling you about 4 different batches, the J2, J18, B2, P18. This colony PCR was done by different students, A, B, and C, but nevertheless, the 4 batches seems to show comparable activity. Okay, so in our lab, we also did some rough calculation. We try to run it like the way the company run, trying to put the dollar amount into it, although even though we're not going to sell this. But basically what we produce is equivalent to a value of about $10,000-ish after you factor in all these other reagent. We did some stress tests also, but for the sake of time, I'm gonna skip it. But just to say that our enzymes seems to be stable even after freeze-thaw cycle up to 10 times. That's the one that we checked, up to 10 times in the absence of cryoprotectant, meaning like no glycerol, just the tag extract. We freeze-thaw them 10 times, and it seems to be retained. It seems to retain the activity. So another stress test we did is the temperature. We try to keep them at certain different temperature for almost 1 day, and it seems to be still stable at 60 degrees Celsius after after overnight incubation. So anyway, here's sort of like the ongoing activity. We're trying to continue the stress test, which important to develop the best formulation for our protein. And also there's other stuff we're planning to develop formulation for the lyophilization, because once we can lyophilize them, it can cut the shipping costs, because our hope at the end is we can distribute this to different colleges across the nationwide, and hopefully by sending the lyophilized form, it can reduce the shipping costs. And we do just have several other exciting things just came last week. We get the recombinant tag version as well as finally the reagent arrived, like the column, the imidazole for the nickel purification, things like that just arrived, and we're excited to start a new phase, if you will, in our sort of like project. So it's just more pictures of students. I like to highlight the students in our project, because essentially this project is meant to help them to get lab experience. So here's just I just want to show you a few things that happened, how I was able to get through the internship this semester. Actually, I forgot to mention that we this spring we have about 18 students and only one of me. So it was like this is 18 students here, and it was just it was quite chaotic, but we're able to get through it by using I form team. I let them form a team of 2 where I give them sort of like this group mission, if you will, overview. Every week they have this overview that they can do, and then I list on the board something like that, the objective of the day, and they knock out one by one. Each team will be held accountable for what the thing they produce, essentially. So here's just some data that I want to show you. This is the data actually from fall 2021 cohort in terms of what sort of thing that the student feels strongly or very strong at the end of that one semester internship, 54 hours. Essentially, most of them believe that they are very comfortable working as a team, knowing the general rules and safety, lab safety, as well as asking help essentially from either the supervisor or the classmates. So and then here I just want to show you the last piece of the three pillar, the research part. We do have other project, including antibody development project. This one is here's a quick plug. This is a part of another NSF project that we will have another hackathon this summer. I think Sandy Porter will be able to tell you a little bit more about that if you want to participate. We do also have this method development that's ongoing, as well as developing microbial barcoding for microbiology class, trying to build in the PCR amplification as well as DNA sequencing and bioinformatics potentially into the microbiology class. And of course, we have this structure function protein engineering type of project as well. Here's our team. I just want to thank everybody that's involved. That's my avatar. That's basically my state of mind every Saturday during the internships. Always like always something happening. So and then here's the co-PI Bruce Ness, as well as our very phenomenal high school instructor partner, Dr. Wendy Wooten from Rosita High, and our industry partner, Dr. Wendy Johnston here. And of course, the most important thing is, of course, the student, because even though we have all this cool and amazing project, what's important is that our focus is on the student itself. So with that, that's I think the end of my presentation. I'm certainly our project is certainly looking for the chance to collaborate, perhaps with also with the DNA sequencing center, our first presenter earlier. We can certainly build something, a supply chain type of network in the future. So thank you very much for your time.
Fantastic.
Thanks, Aron and Joseph and Kasal. There are all such wonderful things going on. I did post a link in the chat for our evaluation. If you have to leave, please fill it out before you go. This information helps inform us, and helps us, helps us give information back to the National Science Foundation. So we have some questions in chat. I think I'll just start out with those. The first one we have is for Joseph and Kasau about the cost of the per sequencing run, I guess.
The total cost from sample to sequence is about $11. About $5 of that is to get to the PCR amplification, and the other $6 is to clean up the PCR, do the cycle sequencing, clean up the cycle sequencing, and then actually run it using the consumables on our sequencer. So about $11 per sample.
$11, yes.
Okay. And I just want to confirm your work is at the high school, right?
It is, yep. So we're located on the Liberal Arts and Science Academy High School campus.
Okay. Let's see. Aron, Nick wants to know if your attack polymerase is available.
We will make it available. Right now, we're still sort of like working on the kink. Working with students. There's some again, we are a new facility. We do not have protocol ready. So as we are talking right now, we're developing the SOP. So yes, once we know our product is good, we will make it available for sure for everyone. So we can actually share our protocol too as well. So.
Oh yeah. Actually, you should publish it in Cubes. But we'll talk about that next week. There's also a question about if the Aspire students get stipends.
We do not have the budget for that, although I'm working with my college right now, trying to utilize the work study for that. But again, still in the ongoing discussion, we do not have any conclusion yet for that.
All right. And Nick was wondering if it's hard when you have a changeover between semesters and you get a new batch.
Yes. So I think I also saw Linea's question whether is it possible to have the student from previous semester to be the mentor. That's actually what we did. So out of the 18 students that we have this semester, 10 of them are returning students. So they spend the first semester already. So now their role will be are the mentor. So we pair up. Out of the 18, we pair up in a group of 2, one mentor and one newbie, if you will, and each of them with a specific task. So yes.
So Sandy, I hope you don't mind me just jumping in. By the way, that is a workforce skills standard in the Washington and Texas skills standards, is the idea that students are mentoring students. So you just met a skill standard too.
Yeah, but we were actually doing it mostly because there's only one of me and 18 of them. Initially, I need to get a help. So that's why I enlisted all these veterans, if you will. So.
And Michelle wants to know if students are evaluated in any way at the end of the internship, although you did show some data.
Yes, we do. We do have also self-evaluation that I did not show the data in terms of sort of like the skill pre-training or pre-internship and post-internship and see whether that increased. I have not get a chance to compile that. We have the paper form, but our evaluator has shown really beautiful data, the one that I just showed you, and there are a few other data that I did not show for the sake of time. But yeah, we do. They were evaluated at the end. Yeah.
And Savita, why don't you unmute yourself and ask your question? I know you've been waiting for a while.
Yeah, thank you, Sandy. So I had a question for the first presenter, Joseph. So it's all very impressive, but how are you handling like the other courses online, the first 2 that you said, or is it hands-on? How are you handling 94 students?
There are different sort of ratios that we use for high school classes compared to most community college classes. So those 94 students are actually divided into 4 sections, and I teach all 4 of those sections. So those
How long are the classes and how many times a week?
They are 90 minutes. They're every other day for an 18-week semester in the fall, as well as in the spring semester.
So, and then it's a part of their high school thing. They get high school credits, right?
Yep. So being dual credit, they get high school and simultaneous community college credit.
SCC credit, yes.
So it's part of it's just built into their high school day.
I guess since in Austin, you guys have been doing this for a long time, that's why students know about it and they enroll, right?
Yeah, so I've been teaching with ACC for the last 14 years. So we started with one course. We had about 14 students, and we've been building it up over the last 14 years. And we're starting to get to this critical mass now where we're, and actually I'm meeting with Linnea and the rest of our college on Monday to talk about this. How do we scale it? Because it's only me here. So we need to bring in other faculty to accommodate these 128 students. And we're looking at different models and ways of doing that because there are very few people on our campus who have the credentials to offer the course dual credit. So that's been an issue for our program in the past. And hopefully we can move forward and accommodate all 128 of these students. The other issue we had is I had no idea we're going to get 55 students who want to do internships next year. Normally I place between 20 to 30 students. And that's because over the last 14 years, I've built relationships with professors at the University of Texas and all of the local biotech industry. Right now, it's going to be a big challenge for us to find 55 internships, even if we offer some of those on campus. And for an on-campus internship, like I mentioned, we have some industry partners who are willing to come in, as well as university partners, but all of them are working full-time. So what we call mentorship will most likely take the role of they come in at the beginning of the semester and start the project. I'm a facilitator in the lab, allowing students to do the research, and then they check in periodically throughout the semester with whoever their mentor is virtually. And then we have some sort of event at the end of the semester. I'd like to keep it, mostly DNA barcoding for those students who are going to do internships in that regard, just because it's a really robust technique and workflow, and the students have already been trained out in those introductory courses. But we also, in years after this, like to open it up to other applications of DNA sequencing, whether it's variant analysis, if they're working with a professor, maybe they're, validating particular sequences from whatever that professor or that company is working on. And if we got a different sequencer, and I've been talking to Linnea about this, even opening up next generation sequencing techniques to do whole genome sequencing or ask other questions related to DNA sequencing that are beyond barcoding.
Chandra, you had a question.
Yes, this is fantastic. I'm telling you this. I'm in Houston, by the way. And I'm so impressed. Lene, of course, I know Lene for a long time. You know, one thing, there are so many questions, but very simply, I'll ask two questions. One, number one is that this internship is only pertains to the certificate one that we were talking about. Just to clarify that.
No, so that internship is the capstone course in the level 1 certificate, the advanced technical certificate, as well as the associate's degree.
Oh, wow.
Mhm.
So we can do the internship in this situation. Now, you said this is all being done in the high school, right?
Exactly. So my students do this in 11th and 12th grade, and they get the level 1 or fast track certificate. But all of those courses that are part of the level 1 certificate are also part of the advanced technical certificate, as well as the associate's degree.
But what about the students who may not be in high school and only doing post-baccalaureate or post-associate ATC only? Can they be part of this internship?
That's yes, is the short answer to that is yes.
Oh.
Yeah. And right now, we're talking mostly about sequencing in the context of this project, but our internships are all over Austin in different local biotech companies. A lot of students have relationships with professors at the University of Texas, so they're interning there. But we want to offer on-campus ones, especially for a lot of our minority students who have transportation issues, can't find an internship, don't have time outside of their school day. If we have an on-site, on-campus internship, it just accommodates their needs and allows them to actually finish the program. But again, the biggest issue we're confronting now is scaling. It's a good thing to be so successful, but now it presents another challenge is how do we find funding to have more faculty and offer more sections on campus? So that's our biggest issue now from the dual credit piece.
Perfect. I'll be contacting you. And
Great. Well, I look forward to speaking with you further about other things.
Let's see, there was another question. Oh, Uwe was wondering how people in Austin get companies to take interns younger than 18. It's a problem in Seattle too.
Another huge challenge for that. And that's been one where we've done different variations of it. That's usually one of the biggest barriers is being 18. So like I said, this year we have 20 students who are interning in local companies. A lot of those were weeded out and were not able to continue in the program because they couldn't find an internship position for that specific reason. In the past, we had more luck at the University of Texas where they would allow interns in who are under 18, but they've since changed the rules at the University of Texas as well. So really the rationale for this project when we submitted it to NSF-ATE, part of it was trying to figure this piece out. And it seems like the answer is having the internship happen on campus.
Send him to Aron.
Yeah, exactly. Yeah, and Aron as well. So, but the issue there is, I'm teaching courses all day, Kasao is as well. So it's another thing to do that. And then on top of that, be here to not necessarily mentor because they're going to have a mentor, but really facilitate the internship experience or basically have an open lab where students can do that.
Oh, wow. I'm just amazed at what you're doing.
Our
Savita.
biggest issue, and if anybody has any other insights into this, is just the in perpetuity piece, the funding. The sequencer will eventually get to end of life. The grant funds will eventually run out. And, there is some local philanthropic money we could tap into, but I don't think that'll be enough. So if anybody has any ideas about how to make, the DNA Sequencing and Genomics Center something that we can make sustainable, great. And the other thing we want to do is open up other research streams unrelated to sequencing that are also opportunities for on-campus internships.
Savita.
Thank you. So the on-campus internships, like, do you want to do them in groups or individual internships?
Most likely groups. That way we can accommodate the number of students we have. And typically students like to work as teams or in
Is
teams.
this a part of a class? Are they here at a specific time or they come and go?
Yep. So that would be a class that meets on campus, hour and a half every other day. We have an AB rotation on our campus. So that would be just an hour and a half built into their school day.
Aron.
That'll be a part of your teaching then, right? The internship class.
That's the issue is that we're going to have to find more than just me. Next year, we have so many students. We're either going to have to we're going to have to figure out some way to select students and not allow everybody to participate, or we're going to have to bring in additional faculty. So we have space available to us. We just don't have enough faculty, and I can only teach so many courses. In addition to running this grant and some other endeavors that I'm involved in as well.
Yes.
Aron?
Hi. So I just wondering, is the sequencing, DNA sequencing service open to other institutions? If so, how much will it cost?
We'd love to do that. So year 2, we really want to focus on this research mentor network. And then in year 3, we'd like to establish a 501c3 nonprofit
Yeah.
and figure out if we could come up with different models to actually generate revenue to sustain the program long term. We've thought about the idea, and we met with some people up in Cold Spring Harbor, who are open to this. What if other high school campuses or other programs sent us our sequences and we just functioned as a core? So our students, as part of their internship, ran the sequencing core, provided those samples, and made it happen. The biggest issue, I think, is going to be just people. We're going to need at least a technician who's full-time, their only job is running that core, and likely more than a technician, someone else to run the program, to help mentor students on how we receive the samples. Once we run them through, how we get that data back to whoever sent those samples to us. Hopefully by year 3, we have some better ideas as to how we can make that financially sustainable in the long term. But just to give you some insight, even here in Austin, the University of Texas at Austin has a core facility for sequencing like most major universities do. And they're having a huge issue right now hiring technicians to run that core sequencing facility. We even recently got an email from the person who runs that sequencing facility that they're no longer offering Sanger sequencing services, which in my mind, I was like, well, perfect. We have an automated Sanger sequencer. We have a bunch of, in quotation marks, free labor for students who are interning. So maybe we could be cost competitive. And the real issue is those students, they can come in and work that hour and a half every other day for their internship. But we would need a technician or probably a few people who are actually running the core to do all the other things that are unrelated to students just loading samples into the sequencer. But to answer your question, we would love to open it up to other people. And maybe by year 3, we'll be at a model where we can, hire on a technician to run it, generate revenue from, sequencing for people who send them in from community colleges, high schools, or any other program who's looking for sequencing services.
Joseph, you said that it costs about $5 per sequence. I'm not talking about the PCR, but I'm talking about the prep and the running.
Yep.
So is that because you're not running enough samples or you're not getting the optimal yield out of the kits? Because the problem is that commercially you can get it done for $3.
Yes.
So I think we need to somehow find some way to get you a little closer to that $3 price break. You have any ideas about how to get it down a little bit more?
Yeah, so right now we're using a cycle sequencing kit from Thermo Fisher. And then for the cycle sequencing cleanup, since we're not running them on 96 well setups or having students run individual samples, they use these edge bio columns that allow them to do the cycle sequencing cleanup. And that's one of the more costly things in there. If we move to, hey, every single time we're running a sequencing or Sanger sequencing, we're running 96 samples, we could do like an ethanol precipitation and some other cost-saving measures to get around using those edge bio columns, which I think would, get us closer to $3. But even then, I think we'd be hovering in like, probably, the $4, upper $3 range. So it's not possible. But to answer your question more directly, it's, we're using a slightly different method than you would if you sent it off to a core who's likely running 96 at a time and doing cheaper precipitation methods for their cycle sequencing products.
Yes, so it may be that students in certain ways you will have kids run individual things and it will cost a little bit more. But as you transition to doing some kind of service, the service itself will then replace some, that per sample, exposure that the kids get, and the kids will get more exposure to other aspects of running a company, like managing lots of sequences and customer relations. So hopefully you'll be able to at least transition part of your operation, to a lower cost per sequence. The other thing is that I think if you got some specific donations from, I don't know what, just to say that in order to run this as a business, we need to get the sequence cost down and essentially get grants that buy that cost down. Because I think you're going to do best if you're actually competitive in some way with a commercial thing, even though that, I know that will be difficult.
I
Yeah,
completely agree. So even if we can't get much lower than $5, if we can find something to supplement that so that we're still charging the customer $3, but we know that it costs us $5 in-house, I think we can make the sell to, you know, whether it's passing around the hat to local biotech companies or local philanthropists and saying, hey, if you give us this amount of money, we can provide this service, and look at all the value added that we get for our students in the program, so on and so forth. So really would be, you know, we're running a business model, but not to financially outcompete people, but meet the same costs so we have customers, and, you know, supplement it with outside funding. And then, you know, showing people to give us that outside funding that we get all this extra value added for student training and keeping our program around. So
I think that's exactly the right way to go about it.
Okay. Well, it's been great seeing you all, and it is time to wrap it up. I want to remind everybody about filling out the evaluation. I'm going to put that in the chat one more time, and we can copy chat now, Uwe, so that should work. And I'm really looking forward to, you know, future talks where we get to hear more about your progress, and also seeing you all at the ATEPI conference this fall, because I'm sure we'll get to hear more about your work there as well. Thanks, Joseph and Sal and
Thanks.
Aron.
And thanks again to Innovate Bio for hosting us today. We really appreciate it.
And remember, we're going to be back next week.
Okay.
Some other great talks as well.
Take care, guys. Bye.
Thank you.
And everything will be recorded, so you'll be able to access it on the website, or is being recorded. Actually, I'm going to